Good afternoon, everybody. My name is Tom Simchak. I'm ESA's Director of Research and Programs. Thank you for attending today's webinar on energy storage and NERC standards. This webinar is being recorded and will be available on energystorage.org, and to all those who registered, you'll receive an email with links to the recording and slides, usually by tomorrow. Questions can be submitted at any time throughout the webinar via the chat box in your browser, and we'll come to those after our speakers. Following the webinar, you'll receive a brief survey regarding today's topic and topics for future webinars. Your feedback ensures that ESA continues to provide the highest value information to you and your organization. All meetings and teleconferences of the Energy Storage Association are held in accordance with our antitrust guidelines. We ask that you abide by these guidelines during today's webinar. Full guidelines are available in the members area of the ESA website. If you're not yet an ESA member and would like more information, you can reach out to my colleague Richie O'Neill. Membership includes free access to all our webinars, including those that are exclusively for members, among numerous other benefits. So please reach out to Richie if you'd like more info. Before we begin, I'd like to give you a brief update on upcoming ESA events. Registration is open for the 2019 ESA Storage Exchange. That's October 15th and 16th in Bellevue, Washington, right outside of Seattle. Storage Exchange, it's an event designed to examine steps necessary to integrate energy storage into the grid and whatever your project, and evaluate different ways that companies are deploying storage to lower costs, reduce emissions, and establish a more resilient grid. You'll find registration, agenda, and more information at that web address there on your screen, energystorage-events.org. And you have 2 more days for early bird pricing. Upcoming in our webinar calendar, on September 11th, we're going to have our regular members-only briefing from Wood Mackenzie Power and Renewables about their quarterly energy storage monitor. So that's the Q3 update. That report covers the sort of numbers on what's been happening in the past quarter in the U.S. energy storage world with deployments, and also updates on their projections for the future. It's always super informative, really great to sort of see where the industry, where things are moving, statistics on what's going on out there. So a great one for members. And on September 18th, we'll be joined again by EPRI for the next installment in our Energy Storage 101 series, this time talking about end uses for energy storage, so important topics like the different value streams and storage in different market sectors, and how those sort of situations might be different for those looking to deploy energy storage. And that one's a free webinar, so you can bring all your friends. And more webinars to follow, both for members and some available free to non-members. So keep an eye on the events lists, both on the front page of energystorage.org and the member section of the website. And if you registered for this webinar, you'll get those alerts on email as well. So today, we'll be learning about standards from the North American Electric Reliability Corporation, or NERC to you and I. NERC develops standards for the operation of the electric power system, including interconnection, but how those standards and related requirements apply to storage isn't always clear. So joining us today to discuss key issues for energy storage with NERC are Michael Goggin, who is Vice President for Grid Strategies LLC, Jill Lower, Senior Compliance Analyst at Utility Services Incorporated, and Dan Copen, Compliance Analyst at Utility Services Incorporated. After their remarks, we'll open up to audience Q&A. You'll be able to ask questions via the chat box at any time. You should see that down the bottom left-hand side of your screen. And we'll read those out for the presenters when we get to the Q&A session at the end. So thank you for attending today's webinar, and I will turn over to Michael. Michael, it's all yours.
Okay, thanks, Tom. Yeah, Michael Guy with Grid Strategies. I'm on the NERC Planning Committee and am generally following what NERC is doing as it relates to inverter-based resources. So I'm going to be talking about that today. It's kind of a catch-all of what all of the activities that NERC has ongoing that could affect storage resources. And then the other speakers are going to drill down in more detail about, particularly on the mandatory standards compliance side, what that means for storage resources. So we kind of provide a broader view, and then they're going to drill down on some of the topics that I briefly introduced. On this first slide, here's kind of an overview of what I'm going to talk about. I'll briefly preview some of the mandatory standards work that's ongoing. A lot of that came out of several grid disturbance events, mostly related to solar PV resources and their behavior during those events, and that has led to some standards activity that the other speakers are going to talk a little bit more about what NERC compliance means and the process of that. I'll talk about a guideline that's coming out shortly that deals with recommendations. And when I say NERC guideline, it's important to note that that's just a voluntary guideline. It's not a mandatory enforceable standard, which is what the other speakers will be focused on. However, I think this guideline is useful and relevant for the industry because it makes a lot of recommendations to transmission service providers about things that they may want to consider when they're crafting their interconnection requirements. I'll talk next about the SPIDER working group, which is a great acronym for the System Planning Impact of Distributed Energy Resources. I think this has a lot of relevance for storage, that's being deployed on this distribution system. Even though NERC's jurisdiction is purely on the bulk electric system, because large aggregations of distributed resources can affect the bulk system, NERC has been trying to coordinate and facilitate discussions about that topic, even though it doesn't have direct jurisdiction. So I'll talk a little bit about that, and then I'll briefly kind of preview a few some other NERC events related to storage and some other miscellaneous NERC activities that relate to storage. So starting on the first topic, and this has been, I think, probably the single biggest focus of the inverter-based work at NERC. I guess just briefly kind of level set, when I'm talking about inverter-based resources, this is basically anything that produces power in direct current and then uses an inverter to convert that direct current to alternating current. So solar photovoltaics, many types of wind generation have some form of power conversion, either partial or full power conversion from DC to alternating current. And then battery storage resources, are direct current and then use inverters as well to transform the DC to AC power that's used on the grid. And so this was an issue that cropped up, as you can see in the chart here, with PV generation. A few years ago in California, you had a wildfire event that caused a large transmission line to trip, that caused a voltage disturbance across a large section of the grid. And many of the inverters at these large-scale, as well as small-scale solar installations, they stopped injecting current for a relatively long period of time. You can see there were several disturbances in this chart here, and you can see that the drops, and then eventually the resources came back, but then they were dropping off after additional events. And I think this caused a lot of concern at NERC because resources need to remain online when there's a disturbance on the grid. There is a legitimate reliability concern if resources drop off, and that can potentially, if you have enough resources dropping off, it could lead to a serious reliability event or even a cascading outage. So, a very legitimate concern here that NERC wanted to look at. And I think even though this is a solar PV event, the same inverter technology is used for battery storage devices, and so all the same software settings and hardware settings and things like that are used in both types of resources. So very much relevant for both solar and storage, and particularly solar plus storage installations that are using the same inverter at the plant. So what has NERC done as a result of this? So they issued 2 reports, the first after the first fire event, and then there was a second fire event where they learned some more, and they put out a report after that. There were guidelines, which again are these voluntary recommendations that NERC puts out. And I think that process has worked very well. the guidelines, I think, have done a really good job of, causing the inverter industry and the solar industry to proactively reprogram and retrofit existing resources in the field, and then on a going forward basis, make sure that the settings don't cause similar events. So just to briefly, talk a little bit about what were some of the causal factors of these these events where the solar generation was dropping out. You had inverters that were sampling at a very high rate of speed, and they were erroneously seeing the grid disturbance as a very large voltage or frequency disturbance. And then because they thought it was this very large disturbance, they were tripping the generation, which is what they are supposed to do in a very large event. However, it turns out that the disturbances, the voltage and frequency disturbances, were not as large as those very initial recordings indicated. So this was basically, the solution here was pretty easy, just to kind of slow down the sampling rate of the device so that it was not getting this erroneous initial reading, but getting a much more settled, after a certain period of time, a settled reading of voltage and frequency, and then deciding what to do. So again, after the guideline, I think that's been largely fixed. There was confusion about when resources are supposed to trip or not supposed to trip in the NERC standards, and so I think there's been clarification around that. And then there's this topic of momentary cessation, which is basically a brief stopping of injecting active current following a disturbance. And this one, I think, is an ongoing discussion through some of the NERC standards work to clarify that that type of that momentary cessation is not acceptable on a going forward basis, and that inverters are expected, subject to equipment limitations, to continue to remain online and to inject current following the disturbance. So again, NERC through the guideline process has, I think, gotten the vast majority of the inverter industry and the solar industry to adopt these changes. There is a particularly through the PRC 24 standard, which governs the protective relay setting standard. There's a drafting team that's currently working on revisions to that standard to clarify a lot of these issues and make clear that mandatory NERC standards specify you are expected to remain online during these types of disturbances, and clarifying some of the other confusion that had caused these events. And there's also the PRC 19 standard, which is a coordination standard, so basically just specifies what you need as a generator to report to your reliability coordinator and transmission provider. So basically, if you do have a plant that has momentary cessation or other things like that, basically just clarifying how and what you need to report of how your plant will behave during this type of event. There's also been coordination with some of the IEEE standards groups that are working on both distributed and transmission connected inverters, particularly the IEEE P2800, which deals with transmission connected inverters, I think is very relevant. And so there's a lot of ongoing coordination to make sure that the NERC standards are in line with the IEEE standards. And then there's a separate NERC group. There's interest in potentially imposing data reporting requirements for inverter-based resources that basically to better understand what the resources are doing during grid disturbances and collect just more information there. So a lot of NERC work related to these ride-through related issues. The other speaker is going to clarify what NERC considers a bulk electric system, what NERC considers to be a bulk electric system device, and therefore what types of generators are covered under these mandatory NERC standards. So I won't go too much into detail there, but you should basically know that there's a lot of NERC work going on in the standards realm that can affect larger scale battery devices. So that's kind of the ride-through issues. I mentioned this guideline. Here's a little more detail on it. This is going to be coming out shortly. I think it's a very good document. It's still in draft form, but I think it's nearly final. I think it makes a lot of good recommendations and really provides a nice overview of what inverter-based resources do, how they perform, their capabilities. And I think this will be helpful to kind of help educate transmission service providers about what they should be thinking about when they're crafting interconnection requirements and interconnection agreements. And so I think this so it can certainly affect all large-scale storage development. because the interconnection agreements that you're signing with utilities, I think, will be shaped by this document. So I think it's been helpful to have NERC go out and I think better educate utilities and others about the capabilities and behavior of these inverter-based resources. So it's a very good document, really comprehensive and covering I think a lot of these different issues that the transmission service providers should be looking at. So that's something to keep an eye on. It should be coming out shortly. Next is for those who do distributed energy storage. The SPIDER working group is, I think, there's a lot of big of activity there. Again, this is outside of the the direct mandate and jurisdiction of NERC, but they do want to coordinate and think about these issues as much as they can, just because they can affect the bulk electric system. So there's a lot of work on resource modeling, modeling verification, how planning and operating studies are conducted, and how they account for distributed resources, and then also coordination with some of the IEEE, the distribution connected inverter team. So the SPIDER working group, I think, is still taking people who want to join. Before the modeling, the verification, the studies, and the coordination groups that are listed here, you can join any one of those and participate according to your interests. So if you're interested in that, certainly I think could be useful if you are active in the distributed storage space. Then on the next slide, I just kind of wanted to mention a few miscellaneous NERC items that relate to storage. There is a workshop coming up in September. It will be hosted in both DC and Atlanta. This is a joint meeting with NERC, the North American Generator Forum, and the Energy Systems Integration Group to discuss batteries and a lot of the issues I just talked about. So it certainly could be of interest to a lot of folks on this call. So I encourage looking into that if you're interested. Another item to have on your radar is that in the next year or so, NERC is going to be starting to phase in reporting requirements for solar resources for the generator availability data set. And this is something that's required of other resource types. They phased in reporting requirements in for wind in the last 4 or 5 years. They're now doing solar, and some of the key issues that they're dealing with there are, how to report if you have on-site storage at your solar plant. And the generator availability data set deals with outage rates, forced outages, things like that. The causes of those outages, and helps NERC better understand what the availability of resources is likely to be, particularly in the planning timescale. So it could be important that those rules are set up and reporting is set up in a way that's workable and not unduly burdensome for the industry. And then the Inverter-Based Resource Performance Task Force, which is kind of the umbrella task force that's monitoring and discussing all the activities I just talked about, is also doing a lot of other thinking about the kind of the distant future where we have a much higher penetration of inverter-based resources on the grid, how that's going to work with low inertia power systems, how we can use fast frequency response from inverter-based resources to provide an inertia-like frequency stabilization, how we can use grid-forming converters, some of the localized issues with weak systems. So there's really a lot of, I think, interesting work being done through the Inverter-Based Resource Performance Task Force. They have regular multi-day meetings to kind of talk through all these issues that I just covered, and then also these more forward-looking topics. So anyway, that's just a quick overview of things going on at NERC. I'll turn it over to the other speakers, and then I'm happy to take questions and comments at the end.
Great. Thanks so much, Michael. Reminder to everyone, you can submit questions in the chat box, and we'll put your questions to our presenters at the end. Next, we go to Jill Lower and Dan Coben from Utility Services Incorporated. Over to you two.
Good afternoon, everyone. This is Dan Coben, Compliance Analyst with Utility Services. And Jill Lower, Senior Compliance Analyst. So Dan and I are going to tag team on this presentation, and Dan's going to start first.
So just to give an overview of what we'll be covering today, we'll be talking about what is the bulk power system, what is the bulk electric system, go into NERC registration, NERC compliance, some electric storage resource compliance quandaries, and some takeaways and questions. And before we begin, it's I think important to say that this presentation really is going to be making clear what some of our assumptions are going into our discussion. So at any point, we're always happy to talk through those assumptions if you have questions about them and to justify why we've made those. So just to begin, as a reminder to everyone, there was a 2003 blackout that resulted in 45 million people losing power. You can see the area in red on that map as the affected area. In 2005, Congress passed the Energy Policy Act, which amended the Federal Power Act, creating Section 215. And that gave the Federal Energy Regulatory Commission jurisdiction over all users, owners, and operators of the bulk power system. I wanted to point out this definition specifically calls out interconnected electric energy transmission network or generation, not including facilities used in local distribution of electric energy, but it's just worth noting that storage, of course, is not included at this time, just in the explicit definition that Congress contemplated in 2005. So something to consider. Section 215 directed FERC to certify an electric reliability organization, develop procedures for establishing, approving, and enforcing electric reliability standards to provide for the reliable operation of the bulk power system. So that meant in 2006, FERC certified NERC, which applied to become the ERO, and Order 672. 2007, FERC approved mandatory and enforceable standards by NERC in Order 693. And as of 2019, NERC is consolidated into 6 regional entities shown here on the map. You can see Northeast Power Coordinating Council, NPCC, Reliability First, CERC, Texas RE, MRO, and WEC. Now, under those FERC orders and others, NERC reliability standards are applicable to only certain entities, those that use, own, and operate elements of the bulk electric system, as defined in the definition of the bulk electric system, which is a bulk electric system, all transmission elements operated at 100 kV or higher, real power and reactive power resources connected at 100 kV or higher, not including facilities used in local distribution of electric energy. And under the BES definition, there are 5 inclusions. Just the high-level titles here: transformers, generating resources, black start resources, dispersed power producing resources, and then I5 being static or dynamic devices. And so what is an electric storage resource? Well, pretty clearly they're not a transformer. If they were a black start resource, they would have to be designated as such. It would be unambiguous. And in terms of the static or dynamic device, that is a device dedicated to supplying and absorbing reactive power only. So that leaves us with I2 and I4. So just to jump into this, I2 says generating resource, including the generator terminal through the high side of the step-up transformer, connected at a voltage of 100 kV. I want to highlight that. It's 100 kV here. And this would be a resource with gross individual nameplate rating greater than 20 MVA, or gross plant facility aggregate nameplate rating greater than 75 MVA. So recently I was at a conference and had the opportunity to ask a representative of NERC, FERC, and NPCC in the room if they each had official positions on how an electric storage resource would be included. And the answer is no, not yet. So what we're going to talk about today is looking at a hypothetical resource, which you can see here has a 30 MVA rating. It has 10 1.5 MVA inverters on each feeder connected at above 100 kV. This would be be the type of resource that would qualify if you interpreted that I2 to be the single unit. Some might say, well, no, each of those inverters is an individual unit. And in that case, you would just add on 4 more feeders, each with 10 of those 1.5 MVA inverters to get a 90 MVA resource. And this would be the type of generating resource that is contemplated here. Alternatively, of course, it could be that electric storage resources are dispersed power-producing resources under I4. It's worth reading the definition here. It would be dispersed power-producing resources that aggregate to a total capacity greater than 75 MVA and that are connected through a system designed primarily for delivering such capacity to a common point of connection at a voltage of 100 kV or above. So the facilities that are bulk electric system are individual resources and the system designed primarily for delivering capacity. So, going back again, it would not be the 20 MVA resource. In this case, it would be the 90 MVA resource. But, of course, it was referring to a dispersed power-producing resource. And we might be hard-pressed to argue that battery storage is dispersed, per se, although it does have feeders. It may not have that same quality of a dispersed resource. So with that, I'm going to hand it over to Jill to talk about NERC registration.
And I just wanted to add on to what Dan had said. When the BES definition was developed, back around 2014 timeframe, energy storage resources were not considered. So the I4 inclusion in the definition was really thinking of things like solar and wind technology, and that's what they were trying to address and whether those are considered bulk electric system or not. So whether NERC would go down the road of saying what category energy storage resources currently fits into the definition or possibly modifying the bulk electric system definition, I'd say that's an unknown at this point, but something to think about. So what I'm going to cover is diving a little bit deeper into if energy storage is required or obligated to register with NERC, what might that look like, and then what are the compliance obligations. So in NERC's Rules of Procedure, Appendix 5B is the Statement of Compliance Registry Criteria, and it lays out very clearly what entities are obligated to register with NERC. If we assume that, energy storage resource is a generating facility, as Dan was covering in previous slides, then that entity would have to register potentially as a generator owner, generator operator. And then those key functional registrations then will tie to specific NERC standards, and then you'll see as we progress through the slides how that kind of lays out the compliance obligations. So again, depending on the region, another sort of key point here is depending on those NERC regions that we showed you in that map, those 6 NERC regions, each of them has a slightly different take on when you need to register. And why that's important is when you're registered with NERC, you get a NERC registration date, you get a NERC ID, and that's the beginning of your compliance obligations. We like to refer to that as day 1 compliance obligations, and we'll dive a little bit deeper here in a minute and what that looks like. So in the Texas region, they have said, and we've asked clarifying questions to them about this point, that you need to register with them when the breaker is closed in for testing. So, any initial generation capacity out onto the grid, you should be registered with NERC. Where another region, MRO, Midwest Reliability Organization, slightly different take in that when you're first producing power and synchronized to the grid, then you should be registered. So some subtleties on when you want to consider registering. And then again, once you do have that NERC registration date and you have your NERC ID and you're in the NERC game, then you're subject to monitoring and enforcement of compliance with all of the requirements outlined in the standards that tie back to your functional registration. And then also as a result, any compliance engagement with a region, you'd be responsible for any sanctions or penalties or mitigating actions that you might have to address if there was a potential non-compliance with a standard. So here's an example of a NERC standard. This is PRC 25, generator relay loadability. And you'll see on the right side of the screen how these standards are laid out in sections. So again, if we're just talking strictly GOP standards, generator owner, generator operator standards, there are 14 categories of standards. And you'll see the acronyms there in the listing of those 14 categories. And then again, within each standard, you're going to see a couple sections that help you to kind of drill down to what are your compliance obligations. So first you want to look at functional entities to see right on the surface, is this applicable to me as a generator owner or possibly transmission owner, distribution provider, all the other functional registrations. So you start there, and then, but you really need to drill down further into the facility section of a standard, which are going to really describe what particular components at your location are really tied and applicable to this standard. So for this example, for PRC 25, yes, it's applicable to a generator owner, but then in the facility section, as you can see, generating units, step-up transformers, and so on, there's currently no language in any of the NERC standards that speak to energy storage resources, so we don't know where that'll all play out. Will NERC consider them generating units, or will they perhaps create another subcategory here in the facilities section of the standard and add that as another obligation? So we're just sort of posing the question right now because it's not very clear. So again, a little bit more about when we talk about day one standards, what are your obligations right when you're registered with NERC? There are a set of standards applicable to all GOPs, and not all of them require demonstrating your compliance position right from your registration date. The majority of them do, but not all of them. Some of them fall into the category more of the nature of if there's a data request or if perhaps your transmission operator needs some information, then you're obligated to provide it. But there are quite a few that do fall in the category of you need to establish your compliance position right up front. And that position can include any number of things. I've listed 4 bullets here of pretty typical types of documentation that you need to have on hand that you would need to demonstrate your compliance position. So things like assessments of determining what you have and don't have at your facility. Capability or modeling studies. A lot of times your transmission planner needs to know what can your site potentially produce and how would that look in a modeling study and how it might impact the whole grid. You quite often have to have policies and procedures that outline exactly what you are doing to demonstrate compliance. And then finally, the evidence to back up those policies and procedures that, again, show how you've met the requirements of the standards. Now, this slide is a pretty brief summary, but just to give you a flavor for what we're talking about, the NERC standards for GOPs fall into, and frankly for all functional registrations, fall into 2 major categories, the cybersecurity standards and then the operations and planning standards. And so in cybersecurity, you need to start with what's called a CIP2, that stands for Critical Infrastructure Protection, and that standard, CIP2, asks you to determine where do you fall in the impact rating criteria, high, medium, or low impact. And I won't get into too much detail, but you just basically do an assessment of what you have and what you don't have. And then CIP3, the other CIP standard, if you determine you only have low impact assets, then you only are obligated to CIP3. But if you do have high and medium, there are a whole other set of CIP standards, which I've not listed here on the slide, so potentially a lot more obligations there. And then in the operations and planning standards, there's again, I've listed by the acronyms, by the 14 categories, some typical standards. In the COM category, that's a lot of communication capabilities, like how do you communicate with your transmission operator. The ELP4 grouping, that's there's a couple of different standards in there. Some have to do with event reporting. The ELP5 is only if you're a black start resource. The facility category, FAC, there's potentially a lot of documentation involved in that grouping, specifically FAC 8, which asks you to document a facility rating of your facility with a methodology and an inventory. It's a pretty heavy data lift standard. And then in the mod category, a lot of modeling studies required in that grouping. The next two, PER5 and TPL7, may or may not apply to generator owner-operators. It's a very kind of small subset that have to comply with those groupings. And then finally, VAR2, which is a voltage control standard. So just wanted to give you a quick overview, a flavor of some of the obligations. But this next slide kind of shows even more detail in this one grouping of standards, the PRC standards, protection and controls. And this is really a lot of obligations for generator owner operators, all tied around your protection systems and your controls. Everything from potentially installing particular equipment to identifying if you've had operations or misoperations of your protection systems. There's a significant standard PRC5 that deals with protection system maintenance and testing, having a plan for that and an inventory, and then implementing your plan and doing your maintenance on your protection systems. That's another in the kind of heavy lift category that requires a lot of compliance obligations and being able to demonstrate that you've tested your protection systems. Then there's a couple of groupings, and again, only if you have very particular types of protection systems. And RAS is a remedial action scheme, not that common for smaller utilities. Then there's a couple PRC standards. It's only if very certain applicability is met. The grouping that I have for PRC 19, 24, 25, and 26, those require a lot of evaluations of your protection system settings, how they are set up, how they are coordinated with your generation. Those require some extensive engineering analysis as well. And then finally, there's a new standard, PRC 27, becoming applicable next year. This PRC category is evolved over the last few years and become a lot more technical in nature, requiring a lot more compliance obligations, and I think we see that only continuing to grow. So with that, turn it back to Dan.
Great, thank you, Jill. So running through that list of standards for day one, the fundamental premise was that we assumed that if the electric storage resource is applicable to NERC standards, that it owns the facilities that are applicable to that standard. But there are some compliance quandaries that arise once you really dig into the definition of what a generating facility is. And a generator owner is one that owns a generating facility. So it turns out that if you really dig into it, a generating facility includes more than just a generator, a generation resource, or generating unit. Facility is defined as a set of electrical equipment that operates as a single bulk electric system element. An element is defined as any electrical device with terminals that may be connected to other electrical devices, such as a generator, transformer, circuit breaker. So what we're talking about is that even if an electric storage resource is a generating facility, capital F, the way that the definitions are written, that does not mean that an electric storage resource is a generator, a generation resource, or a generating unit. Now this may seem semantic and not having that much importance until you look at the standards themselves.
And can I interject, Dan? Those definitions that Dan is quoting are coming from what's called the NERC glossary of terms.
Thank you, yes.
And so anytime you see in a standard something that is capitalized, that means it's a defined term in the NERC world. So you can go back to that glossary and see where those terms are coming from. And also keep in mind some of these definitions are quite old in the NERC world. some from way back in 2007 timeframe when the Federal Power Act was modified, as Dan referenced. So, and there's lots of debate in the industry when standards are being developed on whether these definitions are really relevant today, should they be modified, but it's usually a very lengthy process to modify a definition, and NERC kind of discourages that. So the reality is most people in the industry just live with the definitions as they are, even if they're not really the best.
Right, and they're on the books.
Yeah.
So for all intents and purposes, they have controlling weight, which is a complicated situation, especially when you look at the standards. And so, for instance, SIT 2, attachment 1, specifically with regards to what Jill was talking about with low impact, you need to own a generation resource to be low impact. For FAC 3, which is transmission vegetation management, would an electric storage resource have a, quote, generating station switch yard? Mod 26, as you can see through PRC 25 as listed out, specifically references generators and is for the electric storage resource, it's applicable to entities that own a generating unit. Is an electric storage resource a generating unit? And even if so, how is compliance demonstrated? PRC 24, which Michael referenced earlier in terms of generator frequency and voltage protective relay settings, requires ride-through during system disturbances. Under PRC 24, would that mean that electric storage resources connected at a particular voltage are precluded from islanding? Perhaps. We don't know yet. Mod 32, for attachment 1, footnote 3, it specifically references pump storage entities are included, but are non-pump storage entities applicable? And then for VAR 2, generator operation for maintaining network voltage schedules, is an electric storage resource a generator? So even if you accept the premise that the electric storage resource is a generating facility, it may not be these other pieces of equipment that the standards themselves are applicable to. And going into the premise, right, there are significant reasons to question whether electric storage resource is a generating facility. Looking at Order 841 and 842, FERC found that electric storage resources have these unique physical and operational characteristics, specifically injecting energy from the grid, receiving energy from it. And it's worth pointing out that injecting is not generating. I think you'd be hard-pressed to align those two definitions there. And then FERC Order 842, more importantly, they disagreed with commenters that suggested electric storage resources should be subject to the same requirements for primary frequency response as all other resources. Similarly, they found that physical limitations warranted accommodations for electric storage resources and that accommodations were appropriate. So with that, takeaways here. Assuming electric storage resources are included under I2 or I4 of the bulk electric system definition, significant compliance quandaries and burdens will arise for owners and operators. As Jill emphasized, we don't know whether NERC will pursue this in terms of including electric storage resources under I2 or I4, but there is a significant requirement to, in actually revising the bulk electric system, the definition, it takes a lot of time, it's a lot of effort to get that done. So there's a lot of reason to suspect that I2 and I4 will be the mechanism that they will turn to. The first entities to register with NERC will set precedents. The first ones that interconnect, and you can look into the queues and the ISOs and see that many of the resources that are independent of generation that are about to interconnect are going to meet this threshold. So you can see that it's going to happen in the next few months. And then, with regard to functional registrations, there have been new functional registrations that have been developed in the past. And there's an open question. Would an electric storage resource functional registration ensure that NERC standards are applied to electric storage resource owners in a just and reasonable, not unduly discriminatory way? And of course, is your organization prepared? And with that, we're happy to take questions. Thanks.
Great. Thanks so much. Super informative. Great to hear about some of the key issues that folks will have to be thinking about regarding NERC standards in their projects. Reminder to everyone, you can submit questions via the chat box. You should be able to find the bottom left of your screen. Our first question comes from Randy Stacy. What are some of the key differences in the standards required by each of the NERC regions?
So all of the NERC standards are applicable continent-wide, all of North America, but some of the NERC regions have regional specific standards. There's not a large grouping of those that fall into that category, but there are a few. In particular, MPCC has one. Texas, the TRE region has one, and those are just specific due to those interconnections of those areas of the grid that they needed to drill down a little bit deeper into a standard and have a little more compliance obligations. When there is a regional standard, though, it has to be, in order for it to be approved, it has to be above and beyond compliance obligations from the continent-wide standard. But there are not a whole lot in that grouping.
Great, thanks. Next from Alan Freyfeld, sort of a clarifying question. As of today, is storage not a generator, and thus NERC registration requirements do not apply as of today?
It's an excellent question, and based on the conversations that we have had, we would not be able to say that storage is not a generator. So for all intents and purposes, that determination would have to be made by NERC and would be ultimately an entity that does get a letter of registration, putting them into, giving them a compliance registration number. Ultimately, in that letter, it says you can appeal that determination, finding you to be a GOP. And in that context, would be able to prove out in the context of your engagement with the region that you're registered in NERC itself, what you are, and would then have the opportunity to make the case that you would not meet that definition of being a generator. So I hope that answers the question, but as of today, that determination has not yet been made.
And I don't believe we are aware of any battery unit, strictly battery, being registered.
Right. I think there's definitely going to be units out there today that have battery storage that are sufficient size as generators, but those battery storage units would be part of the generating facility.
Right.
Right. So that facility would be made of generators and an electric storage resource, which again emphasizes the point an electric storage resource is not necessarily a generator.
Right. So that's for standalone storage projects where the question comes into play, not, say, a big solar project that has some generation for load firming.
Precisely.
Sorry, some storage for load firming. Is that correct? So the question arises in regards to standalone storage at this point.
Right, exactly. So for all intents and purposes, it would be that storage unit, there has not been a finding that an individual unit is a generator. But again, we think looking at the bulk electric system definition, it's unclear what else it would be.
Great. Reminder folks can submit questions via the chat box. Follow-on question from Alan Freyfeld. If NERC standards are applicable, are there standards applicable to the physical space of an NOC or operator training?
So just for clarification, the NOC would be referencing what?
I don't know. Mysterious question, Paul.
I guess maybe that's like a control room. Is that? I'm just guessing. That's what the question is.
So if it is a control room, we can speak to that from if that is the question. Jill, would you like to?
Sure. So if they're referring to network
operations center.
So in the if we talk about the wind generation model, typically the wind farms are I don't want to say controlled, but or necessarily operated. I want to be careful with my words, but they're very typically monitored by a remote operations center looking at turbine status, maybe derating turbines. That's a really typical model in wind. And so those centers, though, currently are not registered with NERC, and there's some debate in the industry whether they should be or not. They do, however, and they are actively performing compliance obligations in the NERC space, but it's usually like, for example, for a wind farm, it's the wind farm that's registered with NERC as the GOGOP and not the Renewable Operations Center that's registered with NERC. So it's the owner-operator that would be on the line for any compliance obligations and, possible non-compliances and penalty sanctions and all of that. Typically, when we help our clients with audits, we rely quite heavily on those renewable operations centers to provide evidence to demonstrate compliance. So they're very closely tied together. They are not obligated to be certified, NERC certified operators. Some of them do pursue that, but not an obligation.
That seems like a really interesting, almost kind of, when you were talking about definitions being a bit out of date, it almost seems like the standard's assuming a big old computer or, room full of lots of switches on the site, but not adapted to the IT-based systems now.
Yes.
Our next question from Pablo Tecchioli. Does the gross plant/facility aggregate nameplate rating definition of greater than 75 MVA assume a single, assume a single transformer, For example, would 120 MVA energy storage system with two 60 MVA transformers exceed this 75 MVA nameplate rating threshold?
So if I understand the question correctly, you would look to the point of interconnection, right? So how would that unit, in the worst case scenario, impact the bulk power system? So if you have two transformers that, and what we've seen from a lot of the configurations, right, they'll have two transformers that will feed into a single point of interconnection, that would certainly count towards the collective. To be clear, the voltage of the line, right, has to be at 100 kV or above. So in that case that you're describing, a 120 MVA energy storage system that has two transformers connected to presumably one point of interconnection. If that point of interconnection is above 100 kV or at above 100 kV, yes, that would exceed that, to answer that question.
Great, thank you. Bob Szymanski interjects here to say that any NOC that has over 1,500 megawatts in any interconnect is required to be NERC registered as a medium impact facility, regarding the previous question.
And that's an excellent
Yes, that is true. Yeah.
So where can manufacturers and project implementers best keep up with what's happening and coming down the line regarding NERC standards that might impact them, even if they aren't actively involved in the processes themselves?
Yeah, this is Michael. I can take a stab at that. So the inverter-based resource performance task force is designed to kind of be that clearinghouse where all of the inverter-based issues get discussed. So that's probably the single most relevant. But in general, and that, like all NERC meetings, tend to be open. I'm on the NERC planning committee. That covers a lot of different areas, and a lot of that stuff is not directly relevant to inverter-based resources, although that is changing as inverter-based resources grow. So I'd say certainly the workshop I mentioned coming up in September, and then the IRPTF meetings are probably the single most battery-focused events that NERC puts on. So that might be a good place to start, and then you can learn about other ongoing activities at those meetings and plug in where desired.
Great. And that's an excellent point from Michael. This is Dan. I also am involved with the SPIDER working group, and that working group is going to be producing a number of documents, guidelines, and technical reference documents that will illustrate what are some of the expected performance requirements and or expectations for those resources over time. So those documents themselves, just as resources to read and understand where NERC is headed with this, I think is certainly an excellent place to go. I would also just say, though, that in the incoming months ahead, we will see scenarios that an energy storage resource, electric storage resource, gets a letter from NERC. And in terms of how the next phase goes out, these kinds of cases, as we're all aware, can end up being ultimately decided at the FERC level and perhaps at higher levels than that. And so one of the things to keep in mind is, from an industry perspective, sharing this information and making sure that there's a sort of a common goal of understanding what type of standards will be potentially applicable, and whether or not sticking out with the GOP registration may be the optimal decision, and say, hey, we're gonna stick with this registration, or requesting an alternative. That will be a big decision to be made coming ahead. So certainly something to flag and understand that those conversations are only going to be increasing, especially at the September meeting that Michael's referencing for the NAGF and ESIG.
Right. Excellent. Thanks. Well, that brings us up towards the top of the hour. Really appreciate our three speakers joining us this afternoon. Incredibly informative and great to hear about sort of some of the very complicated issues that face storage projects on the NERC regulatory side. Before we conclude today's webinar, I'd like to once again highlight the 2019 ESA Storage Exchange, October 15th and 16th in Bellevue, Washington. Hope that you all will be able to make it out to that. Really great agenda we put together, looking a lot of more of the technical side of storage deployments. Folks can expect a link to the recording and to the slides coming their way in the next 24 hours or so. So you'll have that in your inboxes soon. If you have any questions regarding any upcoming events or webinars or ideas regarding topics to cover later in the year, please let us know, education@energystorage.org. You'll also get a little pop-up from ReadyTalk with a little feedback box where you can let us know your thoughts. Thanks again to our speakers. Thanks to all of you for joining us this afternoon. Look forward to you joining us on a future webinar. And with that, have a great afternoon and goodbye.